we will start by looking at the relationship between statistics and research methods. Now, the research methods is this course, 201, and statistics is coming, 266. In many psychology programs in this country, these two courses actually are either combined into one, and sometimes it lasts an entire year, or they are often taught in the yoked style, that is, you take simultaneously research methods and statistics. And there is something to be said about that, because here we are looking at your assignment 2 with real data, and the data need to be analyzed. Well, you haven't taken statistics yet. I mean, how do you do that? That's a little bit of an issue. That's why one of the reasons for assignment 2 to be an observation is to make the statistical requirements as simple as possible, not to overwhelm you if you were to do an experiment where statistics is much harder than a chi-square. So the two are like, bread and butter. They go together. And it's only artificially that they are kind of separated into two different courses. All right. So research design, obviously, we just looked at our research flowchart, is a strategy to think about a topic, design a study, use a particular method, collect your data, analyze your data, write up your results. Now, in statistics is only that one little part, the analyzing the results. So in that sense, statistics is sort of subordinate to research methods. However, without statistics, there is no research, because if you don't know what to do with the data, it's going to be useless. So it's a smaller component, but it's a very important component, if probably the most important component. There are many, many different types of statistics. In 266, you will be learning a few. When you move to the lab, depending on the lab that you will be taking, you will be immersed in more advanced statistical procedures that are specifically designed for the type of data you'll be working with. I mentioned to you before that for 330, which is experimental cognitive psychology, experimental psychology, cognition, and perception, you need inferential statistics such as t-tests and analysis of variance, multiple regressions sometimes. If you are taking 333, learning and behavior, you will be doing single case statistics, because you will be working with pigeons, and you will be having one particular pigeon whose behavior you will be analyzing using that statistics, and so on. So each of the 4 labs will have its own statistics. That's why it is. And because it's so massive, despite that it's a small component of the entire research process, it has its own sort of subfield in psychology. Now, many of you are thinking about mental health counseling and stuff like that. However, if you guys were to think about the future in terms of potential psychology career, I would very strongly advise you to think about data analysis, because data analysis is extremely hot. It's a very hot topic, and people who can do statistics, serious statistics, can make lots and lots of money, much more than anybody in mental health counseling. Yes, it will take some training. You may have to get a PhD, but you can do a master's in qualitative data analysis and still make over $80,000 a year easily. Mental health counseling, 35, 40, maybe. It's a very underpaid field. So think about it. All right. So how do we decide which statistical analysis to do? Well, I already gave you some hints. I know it may be a little bit overwhelming for you, but as long as you know your variables, right? If you can identify the type of the variable, categorical versus continuous, and identify the scale, It's halfway through. The next step would be to run it through a statistical program, and the program will take all the steps for you. You don't need to know any of the formulas. You just need to know how to tell the statistical program which analysis to do. So for example, there is number 2 here, that if you are looking at differences between different groups of participants, it's almost always different statistics from if you're looking at the differences within the same group under 2 different conditions. We'll talk more about it when we are studying chapter 10, simple experiments. All right, so what's the definition? Well, it's quantitative data analysis, right? And the data are usually obtained through samples of observations or surveys or experiments. And what we do, we want to know how our sample relates to the population, what kind of variability or variance, that's a statistical term, there is for this particular phenomenon that you're studying. Then you have to go through these steps of identifying the null hypothesis and alternative hypothesis, and then running your statistics and drawing inferences from the samples. That is, drawing inferences from the samples that you will analyze onto the population from which that sample was drawn. And that's why it's called inferential statistics, because you're inferring the results that are applicable to the population based on the results from a sample, because we always work with samples. There is no other way. Okay, and for research methods, it's the progression of investigation of your topic, of your research question. You start with a topic, right? Then you learn how to convert your topic into a claim, research hypothesis. We've been struggling with this the entire semester. And then we will outline the steps that we have to take, and we will decide on the method that we will use to answer our question, and then finally get to the statistical analysis in the middle. Why is it my computer? Okay, good. All right. Again, I'm just trying to bring us back all the way to the beginning when we started with the research flow chart. If we don't have the right question, and that was a problem for many of you in assignment 1, and many of you struggled with the topic for assignment 2, if you don't have the right question to ask, you have nothing to work with. Without the right question, we don't have the variables, and the variables have to be measured, and we do that through statistical procedures. In this case, in this sense, research design and statistics are together, and they both depend on the variables and their measurements. That's why I spend and continue to spend so much time trying to get you to understand what variables are, what their levels are, how we measure them, and so on and so forth. If you're still struggling with that, I will see that in your assignment 2, because it's not possible to write the design and material section without understanding the variables. Spend more time reading about this if you have to. Okay, so now the technical steps. Again, I don't really care about whether you know or would know a formula for a particular statistical test, but I need you to understand why. For example, in your design, which has 2 categorical variables, we cannot do a correlation. As long as you can answer that question, you will be okay. So we have to look at the predictive variables, or what we will call the independent variable in chapter 10, how our participants are assigned to groups. Is it 1 group? Is it 2 groups? Is it 4 groups? And then we also have to look at our response variable, also known as a dependent variable in the experimental designs, and what kinds of scales we will need. Okay, So our frequency claims, there is only one variable, which is the response variable. And all we can do is to say, what is the percentage of people that are characterized by this particular behavior. Okay, so there is nothing else except that number. So there is no predictive variable. This is just percentage of people, number of people that exhibit, depression or happiness or, breastfeeding or whatever else that we might be interested in. Okay, now, of course, let's go back for a second. Once we know that it's frequencies, okay, then we know exactly what we will do with this one number that we have to analyze. Well, we have to decide whether this percentage is significantly different from the rest. Okay, what we are doing, obviously, is our association claims. And because you have categorical variable as your predictor, all of you have two groups, right? Let's say if you have gender as your predictive variable, then you have men and women. If you have age as your predictive variable, and we use that categorically, you have younger people under the age of 25 and older people over the age of 60. If you have whether the person is crossing the street based on characteristics of that person or on something else, again, you will only have these two. So these are pre-existing characteristics of your participants. So there will be two groups, okay? So number of variables, one in frequency claims, two in association claims. So when we have zero predictive variables, that is frequency, how many groups of participants are there? Well, there's one. It's people who are depressed or people who are happy or women who breastfeed or whatever. If we have one predictive variable that is categorical, well, we are looking only at the situation with two levels. So there will be two groups of participants. I already gave you examples, things like gender and age, when age is used categorically, young versus old. So there will be two groups. And if we have two or more predictor variables, which will be the case in complex designs with experiments, I don't think we're going to get to that, we may have as many groups as there are conditions. So if there are two independent variables, each with two levels, we will have four groups. Again, that is not going to be a part of the remainder of that course, but it will definitely be a part of your 266 course. All right, so I'm just repeating again, one group, correlational analysis, two groups, depending on whether it's categorical or continuous, we will have either chi-square or t-test. And if we have four, we will have analysis of variance. And if it's a nested design, a 2 by 2, that's 2 multiplied by 2, giving us 4 groups, we will have factorial design. Again, this last part is only for your information, not for you to learn yet, because it might be over your heads. Just to remind you, I keep asking you this question each time we're looking at variables. If we have a categorical variable, it will be measured either on nominal or ordinal scale, and we will use non-parametric statistics, in this case, chi-square. And if we have continuous variables, we only have two other scales, interval and ratio, and we will be using parametric statistics. And this is t-tests, various kinds. There's at least 3, and analysis of variance known as ANOVA. Okay, yeah, maybe we don't need that. We'll see. Yeah, let's skip that. Where are we? Okay, here we go. Now is the time for you to open your Google Doc. All right, don't forget to send me an invitation. I'm not going to look at your Google Docs right now because we don't have time, but we will definitely look at them on Thursday. So you'll continue to use the same Google Doc individually on Thursday. So let's go through some instructions. You have already created that, I hope. If you haven't, do it now. Obviously, we need today's date, which is the November 10th. There will be questions and little exercises. I think of that as a tutorial. Don't panic if you don't know the answer to one of them. You can finish that later. There will be nothing here that is over your head. So you should be able to answer most of these questions, if not all. So don't worry, I'm not grading that. This is just to get you into the mode of thinking statistically. Right, so whenever you see something in blue, and I will also say so, this is the time for you to act. And if you would like to sort of check your understanding, you can also type in your answer in the chat. I may ask some of you to do so that we are on our toes. Okay. And we will see how far we can get. We may not get through everything, but as much as we can. All right. So now I'm asking you to write some definitions. They don't have to be formal. It's just what you think you know what they are. And these are these 4 terms. So what is a population? What is a sample? You should know the answers to these 2 questions. They come from our sampling chapter 7. The last 2, parameter and statistic, okay, they may be a little bit of something new for you, but that's not a problem. Again, if you don't know what they are, you will be able to fill in the gaps between now and Thursday. So do it in your Google Doc. Again, I'm not looking for formal definitions. I don't need you to Google. Of course, I know you can Google. I want you to think what they are. And if somebody is brave enough to perhaps type in the answer in the chat, what is a population? What is a sample? What is the difference between these 2? I'm going to give you a couple of minutes to do so. So can anybody either type or unmute yourself and tell us what the population is? A large group from which a sample is drawn, and sample is proportional population. Very good. Read it. Perfect. And the reason why we have samples, because we cannot test the entire population, even if the population is smallish. So we can say the population of the entire psychology major at CSI. Does anybody know how many psychology majors we have in our department? We just got this number from the institutional statistics department. Can somebody guess how many of you are there at CSI? Okay, 500. It's an underestimate. Seaver says 300. Oh no, Seaver. Certainly an underestimate. Almost close, Rita. 1092. Oh, 15. Yeah, well, we haven't gone to that number yet, but almost 1100. So we are the biggest department at CSI. Excellent. So now I'm just going to give you a hint about parameter and statistics. They have to do with the kinds of things we do with populations and samples. Okay, so the relationship between parameter and statistics is similar to the relationship between population and sample. Great. Okay, so let's move on. Let's talk about the descriptive statistics. That is the way we describe the sample. Okay, now I'm writing here response and dependent variable in parentheses because remember, response variable is used in association claims and dependent variables are used in experiments and causal claims. So that's the only difference. So I may drop dependent variable at some point. So response variable, right, is the behavior that we are measuring because psychology is all about human behavior, mental behavior. Here is your blue question. If the levels and values of the variable, that is response variable in question, differ in quality or kind, then it is a what type of variable? That should be a very, very easy question for you guys. What does it mean for a variable to differ in quality? Does anybody have an answer to that question? Thomas, I think you can do it. Uh, now remember, Thomas, the dependent variable only applies to experiments, to causal claims. So my question is, whether it is a response or dependent variable, what kind is it if it differ in quality? Vanessa, you have an idea? Take the word quality and think about it. Yes, Jenny, categorical, fine, but it can also be measured on the ordinal scale as well as nominal scale. So I'm looking for a more generic term. You're right, it is. Both of them will be categorical. But if it's the quality that differs, this variable is, use the word quality. Qualitative, yes, Seaver, perfect. Yep. If it differs in quality, it's qualitative. Good job, guys. Now I'm asking you to quickly give me 3 examples of categorical variables and their levels. Vanessa, let's have you to do the first one. While Vanessa is thinking, let's ask somebody else for an example. Chelani, would you give us an example of a categorical variable and its levels? And Jenny just said something. Sadiru, how about you as well? Come on, guys, we need to move faster than that. Good, Vanessa. Sex, and what are the levels? Excellent. That's one example. Race, Sadiru, excellent. Give us a couple of levels. Could be more than two, of course. And Chalani, what would be? Oh, Stephanie says age. Well, right, Stephanie, remember that age almost always is measured with numbers, right? So your little nephew is a year and a half, and you may be 20, and so on. So these are numbers. So these will be not categorical variables. This is not going to be unless you use it as old and young. Cholani, you're not with us? Okay. All right. So now, of course, we have the opposite. We have a continuous variable. The continuous variables are those whose levels of values vary. How? You need to finish the sentence. Okay, so remember that continuous variables quantitatively perfect, Jenny. Excellent. So qualitative versus quantitative. So you can think about categorical versus continuous variables as qualitative versus quantitative. All right. So again, I'm asking you to think of three examples that would represent a continuous variable. And I'm saying some of the levels. IQ test, yes, perfect, which obviously ranges from 0 to infinite. But these are numbers, so we can do mean and mode and standard deviation, stuff like that. Weight, yeah, perfect. Income, yes, good job, guys. Perfect. Easy questions. Fantastic. Now, easy but important, because without the knowledge of these variables and their levels and their types, you cannot understand statistics. All right, let's look at the categorical data again. Nominal, because that's what we will be doing for assignment 2. I'm going to use my favorite example because I don't want to introduce any new stuff. This is our leg crossing behavior that we talked about several times already. Here's my hypothesis that a woman crosses her legs within 2 minutes of sitting down. I'm doing an observation, right? So I'm sitting in the library or in the cafeteria or maybe on the subway car. And the moment I identify a participant, I start my stopwatch and I'm observing this person for 2 minutes and writing down whether that person crosses his or her legs within 2 minutes. And of course, I'm also looking at the predictive variable, which is gender, right? And this hypothesis, obviously, remember I talked about predictions. We have two predictions that come out of a hypothesis. That's in your observation plan. One prediction has to do with one level of the predictive variable, women. The other one has to do with the second level of the predictive variable, which is men. So you need to understand the difference, again, between the name of the variable, gender, and the levels, men, women. You have your own categorical variable that you're looking at as a predictive one in your observation plan. Don't confuse them. I mean, don't be confused. Don't mix them up. That's what I'm trying to say. Okay, so imagine that I'm going through my observation study. Okay, and now I'm doing my observation plan. So in your Google Doc, please answer this question. What is your predictive variable in this example of leg crossing behavior? That should be easy. And what are the levels of that predictive variable? You can have your study in mind as well, so you can sort of answer these questions sort of simultaneously for my example and for your observation. Obviously, I'm going to ask you about the other variable because you have two. This is our response variable. That's the behavior, right? And its levels. Okay. Jasmine, would you tell us what the predictive variable is in the leg crossing example?
I'm honestly thinking right now.
Okay.
I'm a little behind right now.
A little behind. All right. Okay. Not a problem. We'll give you a chance to we'll catch up. Anybody else who would like to do so? Aha. Vanessa, sex, yes, but we prefer to use the word gender just because sex is ambiguous. Right. So our predictive variable is gender. Jasmine, do you think now you can tell us what the levels are? That's okay, Vanessa. You could say sex as long as you understand.
Male or female?
Very good. Yes. Or men and women, one of the two. That's fine. All right. Who can do the response variable?
Behavior? Or leg crossing?
Leg crossing behavior. Very good, Jasmine. And what are the levels?
Yes or no?
Right. Whether the person crossed his or her legs or not within the 2 minutes of sitting down. Of course, if we watch for half hour, then very good. So these are the correct answers. Perfect. Okay. Oh, so the last one also is, how many groups of participants do we have in this study? That has to do with the levels of the predictive variable, right? We just answered that question. Sever, why 4?
I was thinking the gender and if it was a yes and the level. So I was considering like male crossed leg or didn't cross leg, female cross leg or didn't cross.
No.
Oh wait.
No.
Okay, but still that's wrong. Okay, got it.
Yes, it's always the predictive variable that gives us the groups, not the response variable. All right. I mean, you could have an additional variable, let's say the type of cross. Somebody who crosses, just one leg over the other, or maybe a crazy cross, like when you're meditating, that would give us more groups, right? But no, because we have a predictive variable with 2 levels, it's going to be just 2 groups, men and women. Okay, let's continue with this. We already answered that question, right? The predictive variable is categorical or continuous? Thank you, Sever. Categorical, indeed. And the response variable is categorical or continuous? Stephanie, perfect. Categorical. Both. And again, that's why I'm going through this example sort of step by step, because that's what your assignment 2 looks like. You are doing an observation with 2 categorical variables. Okay. Now, I want you to just step aside from assignment 2 for a second. Let's say, so instead of measuring whether our participant crossed her legs, let's say it's a woman, what I want to know is how fast she did that. That is, I will have my iWatch, my iPhone with me, and I will be surreptitiously measuring how long it takes my participant to cross the legs. So I'll be looking only at those people who cross their legs within 2 minutes. So now my sample is a little different. What kind of response variable is it now? Continuous, yes, because we will say 15 seconds or 60 seconds or 110 seconds, right? It becomes numbers. It becomes something that we can apply the central tendency to. In this case, our categorical variable switches to becoming a continuous variable. So we can do all kinds of nifty stuff. The same with age, right? We can make age young and old, categorical, or we can make age, 18, 20, 30, continuous. Not all variables obviously can be manipulated this way. Not manipulated, can be measured in different ways, but some can. Income, another one that you guys offered, income could be measured as low income, middle income and high income, or it can be measured in real dollar values per household. Then it becomes continuous, right? So that's why I say the right question is important. If you decide to measure behavior that's continuous, then you will be in the t-test zone, or maybe even a NOAA, depending on how many levels you have of your predictor variable. Okay, very good. Okay, so now let's assume that we have collected our observational data and we need to make sense of them. Remember, the word data is plural. So we need to first make sure that we have a table. I suggested that you guys use Excel, but it doesn't have to be Excel. It's just easier with Excel. That we can then, where we can count our numbers and then use a contingency table. So let's see how that works. So here is my data from the leg crossing behavior. Now remember, yours was structured a little differently, but it doesn't matter for the purposes of this exercise. So this was a massive study. I had a bunch of undergraduate research assistants like you guys who went out into the field and did the observations. All right, and they came back and we put all the data in one Excel. So here is, who can tell me, looking at this data, how many lines or rows are there in this Excel file? Who can guess? Uh-huh, yeah. So what are these numbers at the bottom row? Let's get my annotation. What are these numbers? Total number of participants in each column. Very good, Rita. So we observed whatever, right? 291. We observed how many men? Well, it's 291 plus 96, right? Whatever that number is. And out of those, so 383 or something like that. We found that 291 of our male participants did not cross their legs, because we just count all these numbers, sum them up. Okay, and Siva is absolutely right. We will have to have 291 rows in this table because this is the highest number. And the next one is 232. Out of those who did cross their legs and who were men, we only had 96. That's this number. And with women, we can see an opposite pattern. We see that 232 women in our sample crossed their legs, while 129 didn't. Okay, remember, that's what you will have. Your Excel will be rows 1 through 30 if there are 3 people in the group, or 1 through 20 if you have two people in the group. So you'll have numbers that will be, of course, different from these. This is a sort of a large observation. So this is what you need for Thursday. Okay, you need these four numbers. Without these four numbers, we won't be able to do our chi-square. So I've said it many, many times. So if you do not have your data, you'll just follow us, and then you'll be responsible for analyzing your own data. And I would like to have at least one person in the group with a laptop or a computer that has either an Excel, or you can do it online, of course. We need these four numbers from your observation. Okay, perfect. Well, what do we do next with this? We are trying to make sense of the data. Really, that's what we're doing. To do so, we need to come up with a contingency table. All right, that's how we call that. Or what the book calls data matrix. Same idea. All right. So now what I'm asking you to do is to draw a table like this in your Google Doc. You use the table function, or you can use tabs. Doesn't matter. All right. I'm going to ask a couple of questions that I will clarify in a second. What is a cell in this table? That's question number one. I also would like you to guess what a margin is and where these margins are. Should not be a very difficult question. They are outside of the table. And then I'm asking you another question in terms of how to lay out this table. Where do the predictive variable and its levels belong? Where do they go? So they can either go here. Oops, I need my annotation tool again. They can either go here, right, at the top, or they can go along the side, so this way. And now I'm sure you can predict my next question, which is where will the response variable go? Again, either at the top or at the side. Okay, I'm going to give you a couple of minutes to create your table, create your skeleton of a table. We haven't filled out the cells yet. So I'm going to number them so that we can talk about this. Let's change color. I'm tired of pink. How about green? It looks good. All right, so I'm going to call this column A, this column B, this column C, and rows 1, 2, and 3. Okay, so who can tell us what is a cell? Where is a cell here? A1, yep, very good. Vanessa, give us another cell. B1, yep, good. Sajiro, another example of a cell. C1. Okay, good. So obviously you just combine the letter with the number, you get a cell. How many cells do we have in this table so far? Well, it's 3 by 3, 9. Very good. Okay, the next question is, where does the predictor variable go? Who can answer that question? Jenny, I'm sure you can answer that question. Where do you think the predictor variable goes? Okay, nice, Jenny. But in terms of this table, axes are good for figures, and this is a table. So choose a row. AC. Okay. Seaver says AC. All right. The A is not.
Siri here. Let me know if I can help.
Yeah. Go away, Siri. We don't need you. We're going to take A1 out of commission just because it's for now. And we're going to do our predictor variable, which is gender, across B and C. Right, so we say gender. Okay. And you're right, Jenny. When we were to do a figure, our predictor variable is going to go on the x-axis. Now, of course, we have two levels, so we're going to say B1 is going to be men. I'm just going to abbreviate that. And C1 is going to be women or male, female. Very good. What about our response variable? Where will that go? To 3. Yes, so we're going to say a leg crossing. That's where it will go, right? And Jenny, what axis is that? Y. Fantastic. Right? Again, we have two levels. We have no, that is no leg cross versus yes. And you will see that in Excel and other statistical programs of JASP, for example, they always line up the results alphabetically. So no is going to be before yes. Men are going to be before women. Excellent. Now, who can guess my next question? What's going to happen with this table now? That's real thinking as opposed to results. Yes, Rita, almost, but be more precise. What results? Let me reformulate this, making it a little bit easier. We have 4 data collected. Very good. We have 4 blank or empty cells in this table. So what's going to go in these cells? You're almost there, Rita. You just have to be precise. How many cells do we have? All right. Yes, B2 is how many men did not cross their legs. Who remembers this number? I don't want to go back to the previous slide. I think it's 96, right? Am I correct? No, no, it's wrong. 290, yeah, okay. Let's erase that. Eraser. Okay, and where's my color? So, why don't you want to change? Maybe this? Erase it, go away. How do I change that? Jesus Christ. Maybe if I do it like this. Okay, so 291. These men. Yeah, well, tell me about Stephanie. I'm crying as much as you guys are. All right, so 96. Yes. Tell me if I'm doing it right or wrong. And women, what was it? 231 that crossed their legs, right? And how many didn't? 129 or something like that? Yes? Okay, you understand where these numbers are coming from, right? They're coming back from the slide where we had our data in Excel. So this is the contingency table that you need for Thursday, because that's the contingency table that we will use to do our chi-square. I also posted a 3-page handout for you to read about chi-square. Again, I don't need you to think about steps as long as you understand why it is chi-square and where that chi-square statistics comes from. It comes from these 4 numbers. Okay, let's have a little think exercise again. I'll use eraser. I'm going to get rid of all of these numbers. And what I would like you to do is, let's say we have, just for the sake of making our life easier, that we have 800 participants in the study. It's actually like 709. So let's say we have our n, n, no, sample size is 800. Without knowing what chi-square does, can somebody tell me what I could write in these cells so that there is no significance, that there is no difference in terms of leg crossing behavior between men and women? Yes, perfect, Siva, right? Does everybody see why? So we will have 200 in every single cell, right? Oh, what a beautiful zero. But doesn't matter, because we are going to come back to the question of margins. Okay. So what we have is margins. And the margins are, well, they are on the side of the table. Actually, I need to get rid of the chat. Okay, so that's the right margin, and that's the bottom margin. Well, why do we need them? Well, because we want to compare the values in each cell. So here is our 200 men that did not cross. Remember, this is not the actual data. We're just playing. The men who did not cross their legs and the women who did not cross their legs, if we subtract one from the other, we're going to get a 0, right? There is no difference. We'll do the same here. No difference. So it looks like the gender didn't matter because both differences are zeros. Now, in terms of leg crossing behavior, well, men who didn't is 200, men who did is 200. So another 0. the same as here. So what we do when we do chi-square, we're looking at these differences in the margins. Now, of course, our actual data are not like this. So let's get rid of these numbers. You guys will have to help me recreate the actual numbers. All right. Get back. So did not cross their legs. What, 291? Those who did, 96. You guys calculate the difference in the margins. What's the difference here? And women who did not cross their legs was 132? No, 232. 232 who did, right? And Jenny, how many didn't? 129. Okay, thank you. Awesome. So now we are calculating 4 differences. Of course, you use your phone or use your Excel. What is the number here? What is the difference? What is the difference here? I'm going to use the eraser to get rid of this. Okay, I'll be waiting for somebody to give me these differences. What is the difference here between these two numbers? And what is the difference here between these two numbers? Okay. And when you're ready, just 195 where, Vanessa? B. Okay. 291. Okay, so the difference is 195. Who can do C for me? It's going to be with a minus, but it doesn't really matter. 103. Okay. Thank you, Seaver. All right. Who can do this difference? 291 minus 129. 162. Thank you, Rita. And the last one, again, will be with a minus, but again, we don't really care that much about 136. Awesome. So now let's think about this. What does this mean? Well, we are interested in the gender effect. We are interested whether, this is our prediction, that women will be crossing their legs more than men. So we could do, right? We can look at these differences. So this is the yes column. 96 men versus 232. So there's a difference of 136. That's how many more women cross their legs. Now, of course, we haven't done any chi-square yet, but you could see, compared to the 0 that we had before, how does it look like in terms of our predictions? Do you think we are confirming the prediction that women are more likely to cross their legs than men? The difference is not a 0, right? The difference is huge, 136. Yes, we probably are confirming that. Okay, and now we expect the mirror image pattern for men. That is, more men will not cross their legs compared to women. And here is the number, 162, right? Looks like a huge number. Okay, and now we will compare across the columns. It looks like 195 more men who did not cross their legs compared to the ones who did, right? Because that's the difference. And with women, it's the other way around. So that's the intuitive understanding of chi-square, is comparison of these differences. Okay? Again, we'll talk more about that when we get to Thursday and talk about your data. Awesome. All right, and so we get this contingency table that you just did. These are cells. We put the predictor on top. Therefore, when we get to the figure, we're going to do the same. We'll have it on the x-axis the way Jenny told us, exactly the way it should be. Right? We put our response variable on the side, and that's going to be the y-axis in the figure. And these are margins. The margins, in this case, the margins are done as sums, but there are many different ways of doing that. So there is more margins here. If we look at this way, in fact, I flipped them because I used female and male again. Remember, they're usually alphabetically ordered, and we can see that in terms of the differences, whether our hypothesis is confirmed or not. Goody. And we can check 708. That's the number of participants. If we sum them up at the bottom, we're going to get 708. If we sum them up at the top, we're going to get 708. So we do a little bit of math to make sure that we didn't screw up our numbers. All right. Here is continuation of our questions. These were numbers, right? Plain numbers, counts, but it can be misleading, right? So a sample size of 700 versus your sample size of 30, it's going to be very difficult to sort of compare if we want to compare two different studies. So instead of doing counts, right, frequency of behavior, 308 people crossed their legs or something like that, we can take the counts and transform them, convert them into what? What will allow us to compare across different studies? And I'm not talking about z-scores. It's not that. So what transformation of raw data will help us understand the patterns across different studies? We had different groups of research assistants going and doing the observations in different parts. How can we compare the patterns? And we are only interested in percentages. Yes, exactly, Jenny, perfect. What we should do is convert, transform the raw numbers into percentages. Okay? So now we can go back to our contingency table. Let's do that, coming back to the contingency table. All right. The question is, what do you assign to be 100? What we will do, that's intuitively simple. We will say that all women, that is 341, is going to be 100%, right? And we will do the same for men. We have slightly fewer men in our sample, 347. That's also is going to be 100. Okay, now you guys use your phone or your Excel and recalculate these numbers by turning them into percentages. So what's percent of men cross their legs if it's 96 men with the 347 being 100? And what is the percent of women or percentage of women who cross their legs if 361 women constitute 100%? So we're going to have 4 percentages now. Let me change the color. I don't think green is really that visible. How about blue? Okay, so whenever you have it, type it in the chat so we can put it on our table. Uh-huh. Okay. So 347 or 100%. What's the percentage of when there are 96? So 96 times 100 divided by 347.
Sorry,
Three.
I may have to redo my math. I
Yeah, I
initially
think.
did 387. I was thinking because I was adding 291 to 96, but I didn't realize I should do 96 divided by 347.
Yeah, okay.
I
So
got to redo that.
redo your math. Okay, not a problem. Anybody else who may have some percentages for us? So let's say for men, we will have 347 is 100%. And now we're going to do 96 times 100 divided by 347. And that's going to give us the percent. Okay, we can do it. Okay. So let's round. So let's make it 28. So Sierra tells us that 28% of men, okay, cross their legs. Well, we don't need to calculate the other percentage. We can just subtract. 100 minus 28 will give us 72. So 72% of men did not. All right, we can give us one number for the women. That's going to be very similar. So we will say 232 times 100 divided by 361, giving us a percentage of women who cross their legs. 64. Okay, very good. So now we have 64 here. Oh, my numbers are getting smaller. That's all right. 64. All right, and 100 minus 64 is going to be 36. So now we don't care really about the sample size anymore because we can compare across different studies by looking at percentages, right? Of course, you could say, well, it matters whether you looked at 700 people versus 30. Yes, that is, we can deal with that. There are special statistical procedures. We don't need to care about them. But what we do care is to see how our sample sort of develops that almost three times as many women crossed their legs than did not cross. Let's talk about men. Almost three times as many men did not cross their legs as those who did. And in women, probably half of the women crossed their legs and did not. Okay, so percentages are very useful because they allow us to recalculate numbers and talk about percentages. Just going back to where we were. We did that. Okay, and now we use the contingency table that will give us this. Okay, and we can say the percentages of men and women, and we can finish the caption here that we can choose one or the other level. We can use the level of not crossing their legs or use the level of crossing their legs. So let's say women who crossed their legs was 72, right? And men who crossed their legs was 28. Okay. Or we can choose the other one. We can say women who did not cross their legs is going to be, oh, no, it wasn't 72, right? It was something else. 64. 64. Right? Or we can do 36 versus 72. And these are important numbers because we will use them to create a figure, because we need a figure for our results. Oops. Let's clear that. Move on. Now these percentages, right, are descriptive statistics. So when I say, okay, I want you to learn a little bit about descriptive statistics, I basically talk about this kind of stuff. In our case, these are the frequencies transformed from raw numbers to percentages. Okay. So what is a descriptive statistic? That's a question for you to answer. Okay. And then once we have that, once we took our raw numbers and transformed them into percentages, we are ready to write a sentence or two in our results. Now, we didn't get to doing that yet, and we only have 2 more Thursdays left. That is the 12th and the 19th. And after that, you will be on your own finishing your assignment too. So we need to learn how to narrate these numbers. I mean, one could say that the mean percentage of women who did not cross their legs was 36%. We can write that as a sentence. That's not very useful because your assignment 2 is very simple, but you can imagine an experiment or a survey or an observation that's much more complex, where you have tons and tons of stuff. Then you're going to be writing these sentences forever. Moreover, people will be reading them forever, and that's not good. We want to make sure that our readers can grasp the patterns of the results very quickly. That's why we have tables and figures. They help us do that. So how do we write a descriptive statistic narrative in our results section? Here is an example. It is in the textbook on page 449. So it's directly from the textbook. Here they talk about mean and standard deviations. We don't have that because our variables are categorical. But we don't really care. All we care about is how to represent the numbers. So in this particular case, there was a study of how strongly people can hit. It was like a punch bag that had the Confederate face. I think we talked about the study in chapter 2. This is a Bushman study of catharsis and anger, where participants were put in the irritable mode by having a Confederate who insulted them. And then the people were either asked to sit down for 15 minutes, do nothing, or they were allowed to, punch the bag, thinking that it might take care of the anger, right? The study. And then they measured whether the participants would blast Steve, I think that was the Confederate's name, with a loud noise. Of course, there was no noise, but people thought they did. So that was the study. So it's Bushman 2002. This is how you write that. So it was a gender effect, right? So they say overall, men hit the punching bag harder than did women. Okay, so here is a little sentence that describes the pattern. And now come the statistical terms. So M is mean. So in this case, 6.69. We don't know what that is. There are no units. Here is a standard deviation. So these two are for men. Okay, and they measured the strength of the punch somehow. And these two numbers are for women. Okay, so women punch the bag at the force of 4.73 with the standard deviation. Now, we are not going to have standard deviation because we don't have central tendency at all. We will only have percentages. And what follows next is the parametric statistical test called analysis of variance. And D is the effect size. All right. We won't have that, but we will have chi-square. So we will have something like this, chi-square. We'll talk about that on Thursday, but here is the format. So you will have to say something like, overall, there were more women who crossed their legs than men, and then give us the two percentages, not calling them means, because these are not means, these are frequencies. Now they go on with the second part of the description of the results, in this case, number of times. Okay, look again at the format. Participants who thought about becoming physically fit hit the punching bag more times than did participants who thought about the person who insulted them. And they're giving us this mean number, 127 times versus 112. Okay, but there was no, it was a significant difference, but not as strong as this one here, because the effect size is much smaller. In other words, participants in the rumination group vented less than did the participants in the distraction group. All right, so see, these are relatively simple sentences, so you'll have to write about your results using this format. Okay, and we'll practice that on Thursday as well. And here they say that if you're not familiar with these terms, you can look them up. But I already told you that M stands for mean and SD stands for standard deviation. Note, that's an important point for us, that all statistical terms, mean, standard deviation, this F is the name of statistical test, ANOVA. You will have chi-square. All of those, and P as well, which is probability. We won't do effect sizes. All of these statistical terms are in italics, and that's the requirement of the APA. Okay, so we'll have to learn how to write something similar to this using chi-square. In fact, there is an example in that reading that I gave you for chi-square, and I'll talk to you about it on Thursday. Oh, let's talk about figures. So you will have to have a figure. We don't use, well, we could use both, but what I mean by both is tables and figures, but we don't have to do it all of the time. We have to decide which of the two formats, a table or a figure, is more telling. And it's almost always the case that the figure is better than the table. But the only difference is when you have lots and lots of numbers, then it's much easier to have a table than a figure. Now, this particular figure is an illustration of APA style required of figures. Now, I'm just gonna, we are not going to have 6 bars because we only have, well, okay, let's maybe, of course, it doesn't matter because they are in complementary distribution. So let's do just 4. Okay, we're going to ignore 6. So what would be our 4 bars? Well, we will have men. Of course, this is from a different study. It's not our numbers. Men crossing their legs versus men not crossing, right? These are in sum give us 100, and these two will be women crossing their legs, women not crossing their legs. Okay, now let's go through some of the APA requirements. Here they say that each figure goes on its own page. APA 7 does not require that for student papers. That means that your figure can be, not can be, but should be right in the results. It should not be the last page of the assignment 2. Figures are numbered consecutively, but you will only have one figure. So it's going to be figure 1. And note that it is in boldface, right? And its caption or the title, it's the same word, is on a separate line, and it's in italics. So you have to think, what will the caption be for your assignment 2? All right. Figure cannot be in color unless you are a neuroscientist, because for the publication purposes, when you print something in color, it costs money, and they charge authors color printing fee. So we're not doing that. We only are using grayscale, dark gray, light gray, black, white. Okay. I'm asking you to prepare, and I'll show you how to do that, your figure in Excel or any other program that has to do with spreadsheets, not by hand, because we don't use handwriting anymore. Note that we have axis titles. Again, this is from a different experiment, not the leg crossing behavior. So, but Jenny already told us that what goes on the y axis is our response variable, which is leg crossing behavior. And what goes on the x-axis is our predictive variable, which is gender, right? There are no grid lines, so you'll see that that's what Excel will do for you. It will put grid lines like this, 5, 4, 3, 2, and so on. We don't use them in APA. And there are a couple of things that you may need to worry about, much like here is the error bars. So these little guys are error bars, and error bars had to do with the variance in the population as estimated through the variance in the sample, which is done by standard deviation versus standard error. We don't care about that. We're not doing that. It says do not repeat the results in the figure if they're also in the text. In our case, we don't care because we will do what we can. We don't have too much stuff to write. And finally, another important thing is Excel will do that for you. It will create a border around your figure. Once you create it in Excel, you'll have to copy it and paste it in your Word, in your Google Doc, without that line. So we'll have to get rid of all of this. Again, I'll show you all of that on Thursday. That's the APA style. If you have any additional questions, I refer you, let me get that, to our favorite book. That is, let me see what I'm showing you. This is our publication manual. We have chapter on figures. And this chapter has an extensive set of rules about figures. So here are some examples. Your figure has to look like this. Again, it's Excel is not going to create an APA formatted figure. So you have to take what Excel gives you and then work with that, change things around. Okay. Close this. So our last thing for today is for you guys to draw. In this case, you may not have time to finish it in your Google Doc, so you can just do it in your notebook or on a piece of paper. I'm asking you to draw a bar graph, okay, using, let's go to the numbers. With percentages, right? So this was 64, this was 36, this was 28, this was 72. So draw the figure in your notebook and let me know when you're done. And that's going to be the end of our class for today. So once you have drawn your figure, if you have a camera, because I know some of you do, why don't you turn your camera on and show the figure to all of us? So the figure should look like this, but with 4 bars, not 6.